The next section after the results section is going to be the analysis section. This is where we really provide commentary on the previous section, the results section. Okay, so we really have two goals. Number one, like I said, is really putting into words what we just showed in the results section through our graphs, through our percent difference calculations, whatever we did analysis wise. And we want to kind of link that back to the purpose of the lab, to demonstrate and explicitly state how those results answer whatever that purpose was, whatever that initial question that we set out to answer was. So the first thing that we're going to have in the analysis question, and this is really, the biggest thing, is we're going to have a concluding statement or statements. Okay, so we're going to look at our data and we're going to make some general statements that we can draw from that data. All right. We want these statements to be big ideas, and what I mean by that is we want to be able to boil that lab down to a few key concepts. So what are the few key takeaways from that lab? All right. And they should answer that purpose. All right. They should provide an answer to whatever the purpose of the lab was. Okay. One really, really important thing that I sometimes see students struggle with is taking a strong stance. A lot of times there's this tendency to kind of waver and not be certain in your conclusion. Okay, what I do is I call this a yellow light. If you think about driving, all right, if you're driving down the road and you see a yellow light up ahead, you have two options. Okay, you either stop or you go. All right, those are the two options. The worst thing you can do is sit there and hesitate. All right, and you sit there with your foot between the gas and the brake, and you're thinking, "Oh, I'm going to go. I can make it. No, I can't. I'm going to have to stop." And you end up wasting time and put yourself in a position where there really is no good decision. All right, when you come up to a yellow light, the best thing to do is decide whether or not you're close enough and you're going to go through it, or whether you're far enough away and you have to stop. And labs are just like that too. All right, thinking about these concluding statements. Pick a side. All right, take a strong stance. I would rather you take a strong stance that's incorrect than have a stance that's wavering, where you say something like, well, you know, the temperature kind of affected this, but not really, but I guess there was some effect. Pick one. Temperature affected it, temperature did not affect it. The other thing too that's really, really, really important is it is okay to say that there was no change, okay? You do not have to have, in a lab where maybe we're trying to see what effect one variable has on another, it is okay to say that one variable does not have an effect on the other. In the words of Enrico Fermi, a very famous physicist, there's two possible outcomes. If the results confirm it, then you've made a discovery. If the results are contrary, then you've made a discovery. So even if you discover that something does not affect it, you might have thought it affected it, but if you find that it does not affect it, that still is useful information. You've still made a discovery. Your data is still useful. So be aware that it's okay to say there was no change. Once you've made your concluding statements, right, we now want to back those up. And that's where this comes in, evidence for concluding statements. And this is probably the hardest part of the lab to do. You want to make your statement, and then you want to look for specific things in the results that back up that statement. Typically, you're going to draw upon your analysis, your graphs, okay, your linearization when we get to the point where we're doing linearizations, anything you did in your analysis, percent error, percent difference. These are good things to draw upon to help to prove your conclusion, right? But you want to be specific, right? So if you're saying that the temperature in the room affects the time, then you need to say, you know, as shown in the graph, as the temperature rises, the time increases by half a second for every degree, something like that. Be very specific in your conclusion or in your analysis section about how your data supports your conclusion. This is a time where you might feel like you're stating the obvious, okay? Do not feel like you're stating the obvious. Be explicit. Be very specific about how your data supports your conclusion. All right. Something else, another common mistake here that I see is people don't use their data; they simply restate it. So they'll have conclusion, they'll write down their conclusion, and then they'll write down something from their data, but they won't actually link the two. Okay, a lot of times your English teachers will get on your case about this because you'll put a quote in your essay, but you won't really use that quote. Same thing here. You need to use that data and state how that data supports it, not just state your conclusion, state the data that supports it, but not explicitly say how that data supports it. Another thing as well to look out for is if you have a situation, you won't for the first few labs, where you have more than one concluding statement, okay? Treat them one at a time. I think that's the best way to handle it. Rather than having all, concluded statement 1 and then 2 and then 3, and then you give evidence for concluding statement 1, but you've already talked about 2 and 3. I think the best thing is to just do your concluding statement, talk about your evidence for that, start a new paragraph, and then do the second concluding statement and talk about the evidence for that. All right, so here we have an example of an analysis section. I'm just going to highlight a few things, point a few things out here. So we start right here with our actual concluding statement. Okay, the data shows that as the length of the pendulum increases, so does the period. Very clear, very concise, a very strong stance here. This is the part that's a little bit tricky, and this is the kind of thing that you want to have. So here's our evidence now. As shown in Table 2, the period increases consistently as the length increases. So there is a reference to our data and how that data supports that conclusion. Okay, and we continue. This increase is also significant, okay, because the percent difference is 92%. That's a great thing to do there, is pick out maybe a number or two. All right, don't restate all your numbers, but pick out a number or two that really hammers home the point you're trying to make. And in this case, that 92% really hammers home the point that the increase in period is significant. All right. And then we have this one last thing referencing yet another piece of data, this graph here, figure 2, which shows the period consistently increasing as the length increases. All right. The last little part of this, all right, from here on, is talking about linearization and talking about a technique that we haven't mentioned yet, so I'm going to skip over that. But it's just going into more detail about how the graph specifically supports this conclusion and actually getting more into the mathematical relationship between length and period.